Hello guys, welcome to my channel. This is me, Sudan. Okay, so let's talk about bit masking. So first of all, let's talk about masking first. So masking means to keep change, remove a desired part of the information. Okay, so let's talk about this image first. Okay, so this is the original image, right? So we mask the image with this. Okay, so first there is the white part and a black part. Okay, so what white part does is it says, okay, we want only this white portion to be in the output image. Okay, and the black part must be removed, right? So when we look into the output image, the only white part is shown to us and the black part is completely removed. So masking does the same thing in the programming. Okay, so we can say the white part as uh, 1 and black part as 0. Okay, so 1 means okay you are in, and 0 means okay you are out. We will be removing you. Okay, so bit masking. Okay, a mask defines which bits you want to keep and which bits you want to clear. Okay, so we have talked this before. So if this colorful, this part is 1, so we want to take this part, right? And so this 0 means we will not be taking this part. Okay, so basically there are there are many types, but we will talk about 3 types here: ANDs, OR, and XOR. Okay, so we have read about ANDing, ORing, or XORing, right? So let's see the example here. Okay, so this is the 1 byte, which means there is 8 bits here, and we want to mask this bits. Okay, so this is saying that we are taking these 4 bits completely in, and we will be removing this portion like this, and this. So this is the output will be like something like this, right? So we only took those 4 bits here, and others we completely rejected. That means the others are 0, right? So this is the AND. And what OR means is we will be taking everything. We will be taking um, this is not OR, sorry, this is XOR. XOR means to toggle. Okay, so toggling means this is input 1, right? So 0 means don't do toggle. Okay, so we are not toggling, so same as the input. Okay, 0 is same as 0, and there's a 1, right? So we are toggling it, so 1 becomes 0, so 1 is 0, and similarly it is the correspondence becomes the answer, right? Okay. Okay, let's talk about more example on bit masking. Okay, so we have created a function called isOdd. So is this the number odd or even? Okay, let's talk more about it. I want to point out some important part, like the odd number has only the odd number has the least significant bit 1. Okay, so let's say our even let's say the number 5. Okay, 5 means 4 plus 1, right? So 4 means, okay, the 5 should be like 101, right? So the least significant bit is 0, this 1, okay? And even number has the least significant bit always 0, okay? So we want to check only the specific part, that is least significant bit, that is this part, and 1 means all 0 except the least significant bit. So if the least significant bit is 0, the answer becomes 0, right? So everything is 0. So that means it is the output is 0. But if the least significant is 1, that means this is a 5, right? So this becomes 1. So output becomes 1. That means it's true. 1 means true and 0 means false. So if it returns 1, then yeah, it is a odd number. Okay, so there is another bonus example, which is a real life example, and we are basically talking about, this is a real life example, okay? So here is a packet, there is an RTP packet. This is a basically different scope. This is a packet we are receiving is 1 byte, the first byte packet. Okay, this packet represent the value 177, okay, and its binary value is 10110001. Okay, so the first byte we receive is 177. That means it has some meaning in binary. Okay, so this is the RTP packet table here. Okay, so this 0 and 1 index represent the version. The second index represent padding, third extension, fourth, fifth, fourth to seven. Okay, 4 to 7 represent CSRC count, and the last represent marker. Okay, so what we're gonna do is okay, let's say we want to know the version, right? We want to know the version. So in programming, we cannot, not in C. Let's talk in like if we are programming in Java, right? We cannot process the bit. We cannot. We only have the power of processing bytes, right? Okay, so we want in a bit. We want in a byte. Okay, so what we gonna do is we want this 0 and 1 index, except this 0 and 1 index to be first. We want to be 0, right? All the value must be 0 except this 0 and 1 index. So what we're gonna do is we're gonna have this mask. This mask is this. We want this all to be 0 except this and this, right? So we are going to mask this. So this is our mask. This is our input. This is our mask. So mask has the 0 and 1 index exactly 1, right? And all the other value are 0. So our output will become something like this. Okay, so these are the only two important bits we want, right? And what we're gonna do is we're gonna right shift this to 6. When we right shift this to 6, yeah, so this is our output, right? So basically it must be from left to right, right? So we are doing this kind of operation here. So after this, we know this is the equivalent value of 2, right? So therefore version is 2. This is the simplest example I can give about real-time, real-life example of bit masking. Hope you did understand what about the bit masking.